We have seen the ways to develop shear force and bending moment diagram for beam in previous video. Now, we will demonstrate how to develop those diagrams for a frame. When we are dealing with frame, we should expect to see axial force developed in member. Consider a 4 meter height frame with base length of 6 meter. This frame consists of a 5 meter length member inclined at 53.13 degrees from horizontal. Loading-wise, assuming the frame needs to resist 2 kN per meter of uniformly distributed snow load. This frame is statically determinate as there are 3 support reactions restraining one continuous member. First, let's determine the support reaction using equilibrium equations. We may first resolve the loading in inclined member into transverse and longitudinal components. 2 kN per meter of loading is resolved into 0.72 kN per meter along local y-axis and 0.96 kN per meter along local x-axis. By taking moment about point A, we can determine the reaction at B. Bear in mind that the longitudinal component of inclined load should not induce any moment about point A. Through calculation, we know By is 6 kN. When we are focusing on inclined member, total transverse and longitudinal loads are 3.6 and 4.8 kN respectively. On horizontal member, the magnitude of force on it is 6 kN. Let's extract the forces and reactions, namely Ax, Ay, and By on structure and form a force polygon. By taking equilibrium in global y direction, we obtain the y component of inclined loads. Then, we use it to construct equilibrium equation with our resultant vertical reaction. As a result, Ay equals to 6 kN. Similarly, we construct equilibrium equation for global x direction and find out Ax is 0. The method presented here is a general procedure which applicable to all types of loading on inclined member. Alternatively, the reactions can be determined easily for this situation. Ignore the frame structure and we can see 2 kN per meter of load is distributed over 6 meter of length. Reactions Ay and By are the same for this symmetrical loading, which turns out to be 6 kN. The segmentization of frame needs to consider the orientation of member. When a member changes its orientation, the internal force function will likely change. For instance, shear force in horizontal member induces axial force in supporting vertical member. In this example, the frame structure is divided into 3 segments. The limit of first segment is from 0 to 5 meter measured from support A. For second segment, we change our reference point to point B and its limit is from 0 to 4 meter. The third segment follows the second and any internal force function is only valid for x within 4 to 7 meter measured from point B. Let's check out the first segment. We need to resolve the reaction forces into transverse and longitudinal components like what we did for the snow load. After that, we can proceed with cutting section and determine the internal force functions. The axial force function is determined by taking equilibrium along local x-axis. This internal force is related to longitudinal component of loading. Then, by taking equilibrium along local y-axis, we obtain shear force function. Lastly, taking moment about point x and we produce the bending moment function for segment 1. For segment 2, the vertical reaction induces only longitudinal force in member. Therefore, we only need to determine the axial force function for this segment. Let's move on to subsequent segment. Unlike segment 2, the reaction By is now acting in transverse direction. Judging from the direction of forces, we should not expect to see axial force in this segment. As a result, we produce shear force and bending moment functions. With the internal force functions we develop for all segments, internal forces in structure can be calculated for every 0.5 meter interval. Then, we plot the axial force, shear force and bending moment diagrams on the structure. Thank you for watching. If you find this video helpful, please share it with your friends. We will see you guys soon. Goodbye.